Vector databases have emerged as a critical technology alongside generative AI. It's disrupting how we store and process information. Hi, this is Sachin, and welcome to Tech Talks with Sachin. In this video, we will unpack this fascinating technology that's transforming how we store and interact with data. Before we dive deep into vector databases, it's essential to understand some core mathematical concepts. Linear algebra. It helps us with vector operations and transformations. Calculus is crucial for understanding optimization algorithms. Probability and statistics are fundamental for analyzing vector relationships and similarity measures. You should revisit these concepts in order to understand internal working of vector databases. Let us revisit some of our traditional data storage techniques. Relational Database Management System, or RDBMS. It organizes data inside predefined schemas. RDBMS stores information in tables and fields, also establishing relationship between these data elements. It uses SQL, which stands for Structured Query Language, to store and retrieve information. On the other hand, a NoSQL DB or Document DB stores non-relational data without rigid schemas, offering flexibility for storing unstructured information. NoSQL is primarily used for its flexibility, scalability, and performance. A database search plays a vital role in information retrieval and further processing. Traditional lexical search match exact keywords, while semantic searches understand meaning and context. This distinction is crucial for understanding why vector databases represent such a significant advancement in information retrieval technology. Keyword searches have limitations, such as exact matching only, missing synonyms, and no error tolerance. In this example, lexical search will only find exact keywords like big applications. If you try to replace big with large, the search will not result in any match. Similarly, macro will not yield any result. Vector databases enable human-like search capabilities. Semantic search can understand that large is similar to big and can even identify spelling mistakes like macro instead of micro based on context. This represents a fundamental shift in how computers understand and retrieve information. Vector databases represent a fundamental shift in data storage and retrieval. Unlike traditional databases that store text or structured data, vector databases store numerical representation of data, which is called embeddings. These spliced databases use AI to understand the semantic meaning of content, enabling more intuitive and human-like information retrieval. To see how informations are processed and stored inside a vector database. Raw information is passed through AI algorithms called embedding models, which convert text or any other content into multi-dimensional vectors. For example, hello world might be represented as a vector with values 0.1 and 0.3. Converted vector values are then stored using clustering algorithms that place semantically similar vectors close to each other in the vector space. When it comes to retrieving information from a vector database, user queries are converted into vectors using the same embedding model used for storage. The system then performs vector-to-vector searches using algorithms like nearest neighbor search or cosine similarity to find the most semantically relevant results, regardless of exact keyword matches. While vector databases offer powerful semantic search capabilities, they face challenges with large content processing. For example, storing an entire 100-page document as a single vector would return the entire document for any relevant query, which will lack precision. To provide focused contextual results, large documents must be broken into smaller, meaningful units called chunks. Chunking is the process of breaking large text into smaller units, meaningful units that can be stored as individual vectors in database. By dividing content into appropriate chunks, the system can retrieve more relevant search results and improve search efficiency and overall user experience. There are a bunch of different chunking strategies and algorithms available. This strategy varies as per the content, use case, and desired search outcome. Each approach offers different trade-offs between simplicity, content preservation, and search precision. Options include fixed size chunking, content-aware chunking, slice chunking, and recursive chunking. Let us see who all are using vector databases. Vector databases are transforming numerous fields by enabling more intuitive and powerful data retrieval. Their ability to understand semantic relationships makes them ideal for applications requiring human-like understanding of contents, such as knowledge-based search, AI assistance, image recognition, and recommendation systems. In today's generative AI and agentic AI era, vector databases play a crucial role working in conjunction with these two emerging technologies. You can use power of a vector database along with generative capabilities of LLM model to implement some amazing enterprise use cases. There are so many vector databases that are available in the market. You can pick based on your need and your overall ecosystem. Pinecone is fully managed and serverless. Vevit is open source and multi-model. Milvus is highly scalable and cloud native. Quadrant offers filtering capabilities, and Chroma provides a simple API for developers who are new to a vector database. There are also a bunch of open source vector databases available in the market which you can download and play around with. Here are some of the best practices which an architect should follow if you are planning to implement a vector database within your ecosystem. Some best practices include choosing the right embedding model, optimizing chunking strategies, and implementing a hybrid search. These practices help balance semantic understanding and exact matching capabilities for best results. Vector databases are evolving. The future of vector database is promising, with trends like performance improvements, multi-model capabilities, enhanced privacy features, and edge deployment. These advancements will continue to push the boundaries of what's possible with vector database. Vector databases represent a transformative technology, integrating with generative AI to create powerful new applications. As the ecosystem grows, we can expect continued innovation and an expanding landscape of solutions for various use cases. Thank you for watching this video. Don't forget to subscribe to this channel for more such technology content. You can also read my blog at www.sachinrahat.com. Thank you once again and have a nice day ahead.